Can you hear me?
Yes, teacher, I hear you.
Okay, I'm checking the recording. Let me check the recording. Where is it? Okay. Previous session. I think where is the recording here? Recordings. Oh. Let me check this one. Yeah, it is there. But how much is this? 1 hour, 13 minutes. What is the problem with the recording? You did not find?
No, teacher, we find it, but the recording is just for our section. If we want to send the link for the other groups or other section,
Okay. I am just sending you the link. Don't worry. This is the link. Okay.
Okay.
I sent you the link. I will send you in the Blackboard. If you can share with your friends. This link is okay. This is the one.
I will check it now.
Yeah, this is in the chat box. You can see.
For last
Yeah, this is yesterday class.
Okay.
This is for yesterday class. But there are two recordings. One is 41 seconds only. One is 1 hour 13 minutes. Do you want to find any other recordings?
No, teacher, just the recording for review classes.
Yeah,
Yes.
it's okay. It's there. It's there. I sent you the. I will send you in the announcement. If you want me to put in an announcement, let me send you announcement. Recording for review class 1. Yesterday was 1. Link. Yeah, this is the link. Okay, it's done. You can find the recording now in your announcement. I did not send in the email, but rather it is in the announcement section. Okay. My voice is clear because actually I usually use the connection, the landline is the LAN, but my LAN is not working.
Yes.
I think it's
Your
on
voice
Wi-Fi.
is very clear.
Okay, that's it. So we will start now. Today we are going to start. Actually, why I changed my, there was one of my friend, actually his mother was passed away. Yeah, I knew it right before your class. So I went there and then to offer condolences. So that's why it was a bit late. This was an emergency kind of situation. So now I'm back. That's why. Let's start the.
Okay.
Okay, so can you see my screen?
Yes, we can.
Okay, let's see.
Yes.
Get slide.
My condolences.
Yes, please.
My condolences, teacher, about the.
Okay. May Allah forgive her and then give the highest place in Jannah. This is my friend's mother actually. So I knew it because of, I didn't know before. I just knew maybe half an hour before, means around 9 p.m. So that's why I went there too. He's in dormitory actually, in jail dormitory. So I went there with my friend. So now, today, we are talking about redox reaction, I think, if you remember, redox reaction. In redox reaction, and then we have to study precipitation reaction. Precipitation reaction. And then the last thing I think in our topics, it was molarity. Huh? You know, one thing more, the topics which is after midterm, it will be 70% of your exam. If we study this one today, it means almost, you know, 80% of the topics after the midterm will be covered in this one. Means the yesterday and today, almost 80%.
Okay.
Okay, so we are studying the redox reaction today, precipitation reaction, and molarity. Molarity is a huge topic. We may not cover all of them, and we will continue for tomorrow as well, inshallah. But redox reaction and precipitation reaction we want to finish today. Okay, so first of all, redox reaction. One voice I cannot hear clearly. I think the voice is so low. I don't know who is this student. Redox reaction. Redox reaction. Let's continue redox reaction. Yeah, I cannot see anything because I am in the PowerPoint now. You can talk to me. You can turn on your mic and then talk to me if you want to inquire anything or say something. Okay, redox reaction. Let's start from redox reaction. Redox reaction, actually, it comes the redox, the terminology redox. It is made up of two types of reaction. We call it red is for reduction and ox for oxidation. We call reduction and oxidation. That's why it's called redox reaction. Oxidation may start from OX and reduction RED. That's why we call it red for reduction and then ox for oxidation. So this is called redox reaction. So first of all, we should know what is reduction, what is oxidation, and then we will go for the redox reaction. Let's see. Again, redox reaction. In redox reaction, first we will talk about reduction. What is reduction? We have many definitions of reductions.
Again,
But the most, yes, please. What is reduction? Do you know? Do you have knowledge about reduction? Yeah. We have, 3 or 4 definitions of reduction, but the most common definition is we call it gain of electron. By any atom, element, compound, or anything else. If it gains electron, it means it is reduced. If anything gain electron, look at this. Suppose we have chlorine, Cl2. And then we say this is 2Cl minus. You have 2 chlorine here, Cl2 will get 2 electrons, will gain 2 electrons, and each chlorine will become Cl negative. We can write like this. So it is addition of electron or gain of electron. So we can say this chlorine gas, which is Cl2, what happened to it? We call it reduced. We call it chlorine has been reduced. Why? Because each chlorine, because we have 2 chlorine here, they gain 2 electron. 2 chlorine gain 2 electron means each chlorine gain 1 electron to become Cl negative. So now we talk about this one. What is Cl chlorine? How many electron we have? 17. How do we know this? Because this is the atomic number of chlorine. Atomic number of chlorine means atomic number give you the number of electron and number of proton. Electron are always negative. That's why each has minus 1 charge. 17 electron will have charge minus 17, and proton have plus 17 charge. What is the total charge? Neutrons are there, but they don't carry any charge, so we don't write it here. So what is the total charge? 0. What is the total charge? 0. If this chlorine now, this chlorine, suppose we talk about only 1 chlorine, and it gains 1 electron. So how many electrons we have for chlorine? 17, and it will gain 1 more electron. We can say plus 1 electron. total electron will be 18, and the charge will be minus 18 now. Okay, and the proton number can never be changed. We know this. Proton number is constant for each atom or element. It does not change. So proton will be plus 17, and then the charge will be minus 1. That's why if any chlorine gain 1 electron, it will go to Cl negative. Why? Because 1 electron will be extra, and it will show itself in the charge. We will write on the top of the symbol of element, okay, like Cl negative. So what happened to this one? This reaction is called reduction. Why? Because chlorine atom gained 1 electron. Electron we can write E or E minus, same thing, okay? Now we go to the other elements, like suppose we have sodium. Sodium is a metal, usually they lose electron. When they lose electron, if they lose 1 electron, it will become plus 1. What happened to this one? Sodium loses 1 electron. It may lose 1 electron, 2, 3, we don't care. Sodium will always lose 1 electron to become sodium plus. What happened to this one? Sodium loses electron, so that's why we call sodium has been oxidized. It means the sodium reaction, we call it this oxidation reaction. Oxidation reaction. And the chlorine reaction, we call it reduction reaction, as we already wrote it. The reaction is reduction, but chlorine has been reduced and sodium has been oxidized. Now we go to the next slide, and then we will make a complete reaction. Look at this. Suppose we talk about chlorine. Chlorine, usually we cannot write chlorine as Cl. Whenever you see chlorine in reaction, you always say Cl2. Why?
Because it's
Naturally
not stable.
occurring chlorine. No. Because chlorine is a gas, actually. Chlorine is a gas. You cannot find chlorine in atom. You cannot find it. It is always in Cl2 form. That's why we write Cl2. But if I need 1 chlorine, I cannot write 1 chlorine is like this. So what would I write? Rather, I will write like half chlorine molecule, which means the same. You know, 1 chlorine or half chlorine gas, the number of chlorine atom will be 1 in both of them. But I cannot write like this. Rather, I will write like this. You got my point?
Yes.
So that's why whenever in chemical reaction you cannot find Cl. Suppose we cannot say sodium plus chlorine, sodium chloride. We cannot see like this. What we see, usually we say sodium plus half chlorine molecule to make it sodium chloride. Or we can say 2 sodium plus chlorine gas, 2 sodium chloride. We can write like this. This is impossible. You cannot see here. This is okay. This is okay. You got my point now? So that's why oxygen always use O2. Suppose sodium react with oxygen. You write like this. You cannot say, usually I found many students, they write like this. Sodium plus oxygen, sodium oxide, suppose. 2 sodium plus oxygen, sodium oxide. This is completely wrong. If you write like this, the teacher will cross it. Because oxygen should not be write O. Oxygen in the reaction should always be write O2, not O. Okay, let's
teacher,
go for this. Yes, please.
And how can I know the like oxygen? It should be 2, not alone, or as you said,
When you
chlorine.
study, when you study chemistry, few things are in 2 form, like O2, N2, H2, okay? And then Cl2, F2, Br2, and I2. Okay, these are the elements which always found in nature is two form. We call diatomic molecule: oxygen, nitrogen, hydrogen, chlorine, fluorine, bromine, and iodine. How many are they? 5. So you can memorize them. These are gases: oxygen gas, nitrogen gas, hydrogen gas, chlorine gas. Chlorine is a kind of gas. Bromine is not a gas, but still it is Br2. Iodine is solid, but still it is I2. Okay, so these are 5 only. You can memorize them. Clear?
Yes.
So these are. So whenever you find, suppose you say sodium, this is not related to our redox reaction. This is general. Okay. Suppose I want to react sodium plus oxygen. I say this is the formula Na2O, and then I want to balance it. I will say this is 1 oxygen and 2 sodium. Oh, this is balanced. This is balanced, but this is wrong. Okay, how can I make it correct? Because O should always be O2, and sodium should be how much? I can make it 4 sodium now, and 2 Na2O. In compound, you can write O, but in elemental form, you cannot write O separately. You should always write O2. This is the proper reaction. Okay? Clear or not? Should we go for the redox reaction again? Let's go for the
Yes.
redox reaction. Yeah, redox reaction. This may not help you in your exam, but it is good for the basic chemistry. We are free now. We can study whatever we want because we don't have the the tension of going to the passing schedule, finish this thing. If we did not finish it, we will finish it tomorrow, inshallah. If you are with me, if you like this one, okay? So let's go for the redox reaction now. Again, we have sodium. It goes to sodium plus 1 electron. We call it this oxidation reaction, is it?
Yes, correct.
Because sodium loses 1 electron. This arrow is very important. It means reactant, and these are products. Okay, products. Sodium goes to product side, but it is sodium plus and lose 1 electron, this oxidation reaction. But where would this electron go? It should go somewhere. It should not go into the space. If there is nothing here, suppose oxidation reaction, so that's why this electron will directly go to chlorine. I will write like this. If I write 2 sodium here, it will be 2 sodium positive, and we will get how many electrons? 2 electrons. Is it okay? If I take 1 sodium, 1 electron will be lost. If I take 2 sodium, 2 electron will be lost because each sodium loses 1 electron only. If I take 4 sodium, 4 electron will be lost from each sodium. Is it clear or not?
Yes, correct.
Yeah. Now we go for chlorine. Chlorine Cl2. How many chlorine we have in Cl2? 2 chlorine. So we will add these 2 electrons to chlorine here, and then each chlorine and chlorine molecule, they will get 1 electron, and each will become Cl negative. When we write Cl negative, we cannot write like this. This is wrong now. This is wrong. Rather, we should write like this now. 2Cl negative. How many electrons have been added? 2 electrons. If you want to complete this reaction now, it means we want to add this reaction. We all have 2 sodium, which is solid. Usually we write the physical state plus chlorine 2, which is a gas. We don't write the gas here. We can write it. And 2 electron will be cancelled with these 2 electrons, is it? We don't write an equation. So here we have 2 sodium plus 2 chlorine negative, but they will immediately make sodium chloride. So we can write like this. So rather we should write like this. It will be better if you write 2 sodium chloride. This is a complete reaction. What about this reaction? This is a reduction reaction. Chlorine gain 2 electrons, each chlorine get 1 electron. But these reactions are not complete. This is a complete reaction, is it? The down one, when we add 2 reactions. So that's why we call it, this is a half reaction. And this is also half reaction. Oxidation reaction is always half. Half means it's not complete. When it will be completed? When there is its counterpart. Counterpart means if there is reduction. So half is oxidation, half will be reduction. When we add these half of, it will become full or complete reaction. So a oxidation reaction is always half reaction. Reduction reaction is always half reaction. Okay, so half, complete, full. So this is called redox reaction. Why we call redox reaction? Because it is 2 parts. Half is oxidation
teacher,
and half will be reduction.
if in the sodium,
Yeah. Yes, please.
I can't hear you well, teacher.
Can you hear me?
Yes, teacher. In the sodium, yes, no, yes. In the sodium, it is gaining electrons. So is it? It should be
No. Where is
reduction,
sodium gain electron?
right?
Sodium, if sodium gains 2 electron, it will be reduction of
2
course.
Na. You're right. Half oxidation reaction.
Yeah. No. Sodium, where it is written sodium gain 2 electrons, sodium lost 2 electrons. That's why I write in the product side. Anything in the product side, it will be lost. Anything, any electron on the reactant side, it will be gained. Okay, I will write again.
Okay.
I will write again. Let's see. Again, the same. Sodium, 2 sodium plus 2 electron. This is the product side, is it? This is the reactant side, R reactant, P for product, and this is oxidation. Why? Because the electrons are on the product side. Now for chlorine, it's different. Chlorine plus 2 electron and 2 Cl negative. This is reduction. Why it is reduction? Because chlorine gain 2 electron. How I know it is gain 2 electron? Because it is on the reactant side. You got it?
Yes, clear.
Yeah. But this is half and this is half as well. So now means if something, suppose we call it, if we talk about a bicycle, okay, this is a bicycle here, okay, you have 2 wheels, okay, here, this is a bicycle, suppose. So how many wheels we have for bicycle? 2 wheels, yeah. So this is a complete bicycle. And then if we remove 1 wheel, it is incomplete now. We cannot ride bicycle with 1 wheel if there is bicycle. So it means the redox reaction actually, it is like this one. It is 2 main parts, one is oxidation, one is reduction. When both are there, so we call it redox reaction. And they are compulsory. If there is oxidation, there must be reduction. There must be reduction. If there is reduction, there must be oxidation. If there is oxidation, there must be reduction. Okay, so they are, we call complementary. They complete each other. Oxidation is half, it's incomplete. Reduction is half, incomplete. When we add them together, we will have a redox reaction, which is a complete reaction. So when we add these 2 reactions, we will have a complete reaction. So this will cancel with this one, and then we will have 2 sodium plus chlorine, 2 means Cl2, and then we will have 2 sodium and 2 chlorine, and they will make sodium chloride, 2 sodium chloride. Is it clear now?
Yes.
Now we will give some more examples. Okay, let's see. Usually metal and non-metals. Do you know what is metal, what is non-metal? The properties of metal, non-metal?
Yes, sure.
One of the properties, we don't talk about the other properties, but one of the properties, metals lose electron. In non-metal, they gain electrons. That's why metal will always, you see metal in positive, is it? And non-metal will always, you see, in negative, like Cl. This is one of the property of metals and non-metal. Non-metal gain electron easily. Metals, they lose electron easily. Did you see any metal like sodium with negative charge?
Never.
Never. You never see any metal with negative charge. Why? Because metal cannot get extra electron. But you see, usually, suppose we talk about iron. Iron means hadid, okay? Fe, Fe2 plus, Fe3 plus. Fe is metal. Fe is not a metal, it's iron. Fe3 plus, it is also iron. We call cation, is it? Cation means positive charge. This is cation. What about this one? This is element. It's not a cation, not an ion. Did you see Fe minus 2 or Fe minus 3?
No.
No. Why? Because metal, either they will be in elemental form with no charge, or they will be found in plus charge. It means they will lose electron. Okay, this is a good property of metal. We will study this one now. So we have, suppose, Fe2 what happened to this element? Fe2 plus goes into Fe3 plus. What happens?
Oxidation.
Is this oxidation reaction or reduction reaction?
No.
Oxidation.
What do you think about this?
He become lose one electron more.
Any other student? Is this reduction or oxidation reaction?
Oxidation.
Oxidation reaction. Why?
It loses one electron.
Look at this. +2 charge means shows this iron has some electrons. +3 means here the iron loses 2 electrons. Here the iron is in the form of losing 3 electrons. Of course, if from 2 electron to 3 electron, it will lose one more electron, is it? So it means whenever the iron goes from +2 to +3, it means it will lose one electron. It will lose one electron. So we can write here. When it loses, we'll show in the product side. And what about this one? Copper. What happened to this one?
Use.
What happened to copper?
Reduction, which is gaining of electron.
Look at this +2. It means it loses 2 electron already. It lost electron. We don't care about when did it lose electron. We will only check in our equation. In equation on the right hand side, copper is +2. But if it gets 2 electron, this is gain of electron. To become copper, metal. So it means it get 2 electron here, it lose 1 electron. If we have 2 iron, it will become like this. So we want to complete the reaction, it will be like this. 2 iron, 2 plus copper, 2 plus, and then this electron will be cancelled, is it? We want to make it balance. So it will be 2 iron, 3 plus copper.
Teacher,
So this is a complete reaction. Yeah.
there was a question in the quiz, which is says how much the total electrons
Okay, we
lose
will
or
see. We will
gain.
see. We are going towards that one. Just wait a minute. I will charge my laptop. I think I will bring the charge. Okay. So now we go for the next equation. Suppose we have this one. Before this, I think I did not talk about the acceleration number. Huh? Let's talk about acceleration number. And then we will go for the acceleration number. What is acceleration number? Do you know acceleration number? Apparent charge on any atom or element. Atom or ion is called acceleration number. Apparent. Apparent means what do you see on any element? Suppose we have sodium. Do you see anything on the top of it? No. Chlorine. Do you see anything? No. Calcium. Do you see anything? No. Helium. Do you see anything? No. So it means all free elements, you know free elements?
Yes, teacher.
Free elements, the elements which are in the periodic, which are written in the periodic table. Suppose we write H, Fe, He, Cl, F, S, O, all these are free elements. If you have free elements, the acceleration number, the charge on them is 0 always. No charge on them. Free elements, they have charge 0. Now, most important thing here is, we know, maybe you know it already. There's one more thing, we call it homoatomic molecules. These are homoatomic molecules. You know, these are molecules in which the same element are combined together, like Cl2, O2, O3, H2, I2, N2, and then in Cl2, how many chlorine we have? 2 chlorine. In O2, how many? 2 oxygen. O3, how many? 3 oxygen. H2, how many? 2 hydrogen. 2 iodine, and 2 nitrogen. All of them, they are 0. So it means in chlorine, both chlorine are 0. Oxygen, both oxygen are 0. 3 oxygen are 0. 2 hydrogen, both hydrogen are 0. But we don't write 0 here, but they are 0, each one. So you should keep this in your mind, okay? When we go for the redox reaction, we will need these information. Okay, let's go again for the next slide. So now we have elements. Suppose we have a zinc sulfate, a compound. We have copper chloride, we have a compound. We have iron sulfide, we have a compound. We have iron chloride, and then we have iron chloride again, and then we have what else we should have? Suppose we have chromium hydroxide like this, or you can say chromium chloride. Okay, we have chromium chromate, or we can say Cr2O7 and then H2, suppose like this. So these are I made compounds here. The most important thing in these compounds is most of them, they are, if you look at this, we have metal and non-metal, metal and non-metal. So here we talk about this one, zinc. Do you know what is the charge on zinc here in this compound? What is the charge on this iron? If you cannot find the charge, oxidation number, you cannot find this oxidized or reduced. Can you know how to find it out?
Yes.
What is the difference between FeCl2 and FeCl3? What is the difference?
+3 +2, the electrons loses.
Chlorine, it is group 7 element. Most of the time, group 7 element, they will be -1 always. Like chlorine, bromine, iodine, fluorine, there are -1. So here, if you have FeCl2, you have 2 chlorine, you don't know about iron, and then this will be 2 negative, so iron should be 2 plus. If we have FeCl3, 3 chlorine means this is 3 plus. But the best way is if this is a binary compound, what we guess actually, if FeCl2 we have it. So what is this one? You just go to the charge. So this is the charge of iron. If FeCl2 means 2 plus, iron is metal, it should be plus. If we have FeCl3, look at this. This will be the charge on iron. We call oxidation number, oxidation state. So iron sometime, you know, if we go to the next slide, so iron sometime it will be like this.
Isotopes.
And sometime it will be like this. If suppose somebody give you this equation like FeCl3 goes to FeCl2, and then he asks you what happened this here. What happened? You will say oxidation or reduction?
Oxidation.
What did I write?
Reduction. Why?
Why? Why? This is my question.
Because it was the +3 ASS and then became +2. +1.
Now, this is important. Listen, this is important. That's why I asked you. Because you should know, before this, what happened? I don't know what happened. I should find what happened to it. So to find it out, you should know what is the oxidation state of iron in FeCl3 and what is the oxidation state of iron in FeCl2. Okay? So if I know it, it means it's easy for me. It is easy for me. So iron goes from 3 plus to 2 plus. What happened? What do you mean by this one? It means it gained 1 electron from somewhere and then goes to Fe3. If we add 1 electron, it will become +2. The question is, sometime maybe some student, they are not aware of this one. Fe3 plus and Fe2 plus. Iron, if it is element, suppose iron, an element, how many electron we have? 26. And Fe2 plus, how many electron we have? Remove 2 electrons from it. 24. And Fe3 plus, how many electron we have? Remove 3 electron.
23, yes.
So we are going from 23 electron to 24 electron in this case. Fe3 means 23 electron iron, and then we are going to 24 electron. So what happened? If we get 1 electron, it will be go to 24.
Gain.
Got it? It gained 1 electron. But it's really difficult to know the number of electrons or how many electrons. No, it's a complicated process. So I will give you a short way how to know. Okay? Let's go for the next slide. Suppose we have this one. Okay. This is a 0. Okay. And then this is a coordinate, plus 1 plus 2 plus 3 plus 4. You know this, which coordinate is this one? Y?
Yes.
And this is minus y, is it?
It's oxidation increase.
You just understand this one. It's easy. You have this in your mind. Now, if anything goes from plus 3 to plus 2, it means, look at this, in this graph, it's going from top to bottom, is it?
Yes, again.
Plus 3 is here. Plus 3 is here, it's going to plus 2. Whenever you're going to the bottom in this diagram, it means this is a reduction. You're going down, it is a reduction. If you're going up, it means this is oxidation. Okay, now we go for the chlorine. Chlorine, go to chlorine minus 1. Chlorine, it was 0 before. That's why we did not write anything. If you go to minus 1, where is 0? You're going down or not?
Not teacher.
Yes, down from 0 to 1. Down.
You're going down.
But
0
teacher,
to minus 1. This is minus 1. Minus 1 is here. Yes, please.
the power one, we doesn't write it, teacher. Not
Where? Here? No. Usually for 1, we don't write minus 1. We write minus only. Minus means minus 1. When we write 1 minus, it means this is minus 1, okay?
okay.
Minus means minus 1. If it is more than minus 1, we will write minus 2, minus 3, minus 4. We write the number. But for 1, we don't write the number. We don't write like this, Cl minus 1. No, we don't write it. We write just only Cl minus. It means, understood, this is minus 1. If anything is plus 1, we don't write sodium plus 1. We don't write it. We just write sodium plus. We write plus, it means it is plus 1. You got it?
Yes, thank you.
Okay, now we are going, suppose we have iron, suppose copper. Copper is to copper 2 plus. What happened to this one? Copper, nothing is written, it's only single element, it means it always should be 0.
Teacher,
You're going from 0 to plus 2. Look at this, oxidation. Yes, please.
is it the same if we say reduction or reduced?
No, reduce is a verb actually. Reduction is a noun. You can say it is a noun.
No, I
So
mean,
it doesn't matter. When we talk about a specific element, we say reduced. When we talk about reaction, we call it reduction. Reduction is a reaction. Element will be reduced.
So when they say like chlorine, is it reduced?
Reduced, yes.
It's a
Chlorine
difference
is
between
reduced.
the. Oh, okay. I got it.
Reduce is a verb. You can change into the past, like reduce, reduced, reduced. Oxidize, oxidized, oxidized. This is the past participle, okay?
Yes.
But for the noun, you say reduction or oxidation.
Thank you,
So
teacher.
now this reaction is, we didn't write the number of electron, but we know it. This is copper 0 to plus 2. Definitely there will be 2 electron here. We don't write it, but we should know. Okay. Now we have another reaction, which is a very common reaction, very famous. We have like zinc plus copper chloride, and then we have zinc chloride plus copper. What is this? This is a redox reaction. Zinc is here and copper is here. Okay, I will go to the next slide, so we'll make it like this. Zinc, we write S solid plus copper chloride, we call AQ, this is a solution. And then we have zinc chloride, this is AQ plus copper solid. Now we have copper here, chlorine is here, minus, this is minus. Chlorine does not oxidize, does not reduce in this equation. How? If you write the equation, complete equation, so ionic equation, you will write like this: zinc solid plus copper chloride is a electrolyte, it will give you copper 2 plus 2 chloride, which is each one is -1 here. Okay, go to the product again. Zinc here, look at this zinc. Zinc is chloride, it means zinc is +2 here, +2 chlorine, negative, plus copper. Now we want to the spectator ions to remove the spectator ions. We will study in precipitation reaction, but I want to know it here. Let me go for the precipitation reaction. Okay, let's see. Because these chlorine 2 here, chlorine 2 here, is the same, does not change anything.
Yes.
Same charge, same number. We can cancel them out. Okay. So what is my the net ionic equation or net equation? Plus copper 2 plus 2 plus or 2 plus 2, it's same. Okay, equals, and here is zinc 2 plus equals plus copper, which is solid here. This is your net ionic equation, our net equation. What happened now? Whenever you have a question like this, you should be very careful. Look at this. Now what we are going to do, we have to talk about zinc. Talk about zinc here. Zinc on the reactant side, zinc on the product side. And what about copper? Copper on the reactant side, go to the copper on the product side. What happened to copper? What happened to zinc?
Zinc oxidation, copper reduction.
Zinc loses 2 electron. We call it oxidation here. This is oxidation.
Yes.
It means -2 electrons. Zinc loses 2 electrons. Now what about copper?
Reduced.
Added 2 electron, this is reduction or reduce. That's it. How many electron are being transferred? It means zinc 2 electron loses 2 electron. These 2 electron will be added to copper to make it copper 0. So copper is reduced and zinc is oxidized. So we can say zinc oxidized and copper reduced. Okay, clear? How many electrons have been transferred? Of course, 2 electrons. Clear or not?
Just 2 electron, teacher.
Plus 2 electron means when we add 2 electron like this, we added 2 electron. Plus, if you don't write plus 2 electron or -2 electron, it doesn't matter. When you write oxidation means it's loss of electron, you can say loss. And here you can say gain. Okay?
Okay.
Clear?
Yes, clear. But
Teacher.
now
Okay, wait a minute. Now I want to know the electron. Look at this. We will write separately. First, I want zinc. Zinc here in the reactant side, I will write zinc. Zinc on the product side like this. Zinc loses 2 electron, I will write here, is it? We call this oxidation reaction. I will write OX, oxidation. What about copper? Copper in the reactant side is +2, is it? On the product side, copper is CuS, means it's metal, it's 0. So it means it will gain 2 electrons. And this is called reduction, RED, I will write RED. If I complete the reaction, if I add the reaction complete, it's a half reaction, both of them. So you will have the same reaction like this. Because the 2 electron will be cancelled out. This one. The 2 electron will be cancelled out when we add it. This will be cancelled with this one. And only reaction will be left like this. That's why we don't see electrons here, because this is a complete reaction. Electron have been cancelled out. 2 electron lost, but it immediately taken up by copper. We don't see electron. There is no electron in the solution. They are in the elements, but transfer of electron. Yes, now, your question.
Teacher, in the exam, if there is a question that how many oxidation here in the element in the reaction.
Yeah, you will say
one
zinc
or
has
two?
been oxidized. Zinc has been oxidized. How many electrons have been lost? 2.
It's 2, the solution. The solution
Which
will be
one?
2 or 1 in the zinc.
Zinc loses 2 electrons. There's no in the solution. Here, you talk about this one?
Yeah, in the exam, if there is a question, that's how many oxidation here?
No, we don't say like this. In exam, we will ask you, suppose if there's a question, it will be asked like this. How many electrons have been lost
Okay.
or gained by an element?
2, you say 2.
Okay, you will say zinc lost 2 electrons and copper gained 2 electrons. It means only 2 electrons have been transferred from zinc to
the copper.
To cover or Cu.
Okay.
How many electrons have been traveling? 2 or 4 or 10? How many? 2 electrons are traveling, only 2. Okay? Only 2 electrons, so 2 electrons have been lost or gained. 2 have been lost by zinc, but 2 have been gained by copper, so it means only 2 electrons are there.
Yes, correct.
Should we go ahead or not?
Yes, go. But
Now there is one more thing, we call it activity series. I should. Yes, please.
Now is 11:30. I don't know if someone have a final classes tomorrow or some.
Zinc.
Okay. You hear me, teacher?
Yeah, please.
All good, teacher. Could just continue.
What do you want to say?
What I want to say now
No,
is
if you want to continue, it's okay for me.
No, I
Yeah,
have no
11:30.
problem.
If you want to sleep, it means it's sleep
But
time, or you want
others-
to leave. It's up to you.
No problem.
Okay, I think give me only 10 minutes more. So I want to finish this redox reaction topic. Okay, only 10 minutes. Then we will leave this session, and then we will start the precipitation reaction tomorrow. Okay, let's see. Okay, let's see. Well, we have activity series. Suppose sometime, if I can go back, keep it here. And this, I want to share with you something. There is a okay, where is it? Yeah. Redox reaction with me. If we have table, I can show you this one. Yeah, this one. Oh, where is it? Yeah, this one. Can you see this table?
Yes, we can.
Can you see the table?
Yes, teacher.
Yeah. This table actually, look at this, we call, yeah, this is a table, and there's all metals. We know metal lose electrons, but we know sometimes metal get electron. If you remember right now in the previous, we write like this: Cu2 plus gain 2 electron to become Cu. But still it did not go into negative, is it? Because it has already lost 2 electrons somewhere. It only got its own electron from somewhere else and becomes 0.
Yes, correct.
Okay, so now we have all these are the metals. These are metals. But we have lithium, potassium, barium, calcium, sodium in one group. Magnesium, aluminium, manganese, Mn, zinc, Zn, Cr, chromium, iron, cobalt, Cu, nickel, Ni, 10, Sn, and hydrogen is here. Forget about hydrogen. We have copper, silver, mercury, platinum, and gold. So which one is on the top?
Lithium.
About
Which one is on the
hydrogen.
top of the series elements?
Alkali metals.
And which one is at the bottom?
Gold.
Gold. Why? We don't know. Okay, but I will give you one example. Why the people, if you have a gold, you want to sell it after 100 years, what will happen to the gold?
Nothing.
Can you sell it? Yeah, means nothing will happen. It does not react. It will still be the gold, the same gold. After 100 years, after 200 years, after 300 years, gold never oxidize. That's why it is on the bottom. Look at this. It means gold never react. It react, but very slowly, or it's a very highly stable metal. That's why we use it as an ornament. The gold is the most famous metal among the human being. Why? Because gold never lose electron. It will lose electron, but very hardly. That's why it is on the bottom. What about lithium? Highly oxidizing, highly oxidizing.
Yes, we
Okay.
have this rate
Now
for
this table shows you. This table shows you who will lose electron fast, who will lose electron slowly. Metals. So lithium is very highly oxidizing. It will immediately lose electron to become lithium plus. And then potassium, and then barium, and then calcium. Sometimes we react one element to another one. Suppose we have manganese and we have chromium. We react them together. Manganese plus chromium. What will happen? One of them will lose electron, one of them will get electron. Who will lose electron when we react them together? Manganese will lose electron. It means it will oxidize. Why it will oxidize? Because in the activity series it is above, and chromium is in the activity series below. So the below element will always reduce, and the above element will always oxidize. You got my point? So
Yes,
this
yes.
activity series gave us a useful information. If any element, two elements, you want to react them together, suppose we have cobalt and we have copper. We react them together. So what do you expect from this one? Who will lose electron? Cobalt or copper? CO, cobalt will lose electron, means oxidize. And copper will gain electron, it means reduce. Why? Because the position of the elements in the activity series. Can I do the reverse? If I say, no, we have copper and we have gold. We react them together and then we say that gold will lose electron, oxidize. Is it correct?
No, teacher.
No. So this is the most important information we can get from the periodic activity series. If you have a question like this, you will be given this activity series. No need to memorize this one, okay? If you have a question in the exam, so it will be there with you in the exam.
Okay.
So activity series give you information when you react two elements together, which one will lose electron, which one will gain electron. The one which is above, it will always lose electron. The one which was below, it will always gain electron. Clear?
Clear.
So this is the only thing.
The gold always, teacher, gain electron?
Always gain electron. If you react with other elements, suppose you react with copper, gold react with copper. Who will gain electron? Gold. Who will lose electron? Copper. But copper, if you react copper with iron, who will lose electron now? Iron. Who will gain
Iron,
electron?
yeah.
Copper. If you react iron with manganese, who will lose electron now? Manganese, not iron.
Manganese.
And if you react manganese with sodium, who will lose electron now? Sodium. If you react sodium with lithium, who will lose electron now? Lithium.
Lithium.
Like this. So if anything which is above on the top of the in the activity series above, it will lose electron, oxidize. Lose electron means oxidize. Gain electron means reduce. It means if I have a lithium and sodium, who will oxidize? Lithium or sodium?
Lithium.
Okay. If I have a cobalt, wait a minute. If I have a cobalt and then I react with iron, who will oxidize? Iron or cobalt?
Iron.
Iron. And cobalt will reduce. Why? Because iron is above cobalt in the activity series. Yes, now, what did you ask? You asked something? Somebody?
No.
Okay, let me, let's see some, there's one reaction. I want to see some reaction. Yeah, this is the common one. Let me go first. Oh, I want to see some other reaction. Let me go for this one. This is the one we are, yeah, this one. Look at this. We have copper and then we have silver nitrate. In compound form, always metal, they have, usually the metal in the compound form, they have positive charges, okay? If element is alone, it means metal alone, it means there is zero charge. Look at this. This is a complete reaction. Now, the question is, which element is oxidized, which element is reduced? First of all, if you know the activity series, this is not, the activity series may not be given in this equation, okay? No need for the activity series. The reaction is always given to you. Now, you know this copper, it is alone, it is zero. Copper here is nitrate. Oh my goodness. Do you know what is a nitrate? If you don't know nitrate, it is like this. Nitrate is only -1 charge. You have two nitrates here, so it means -2 charge. To have a neutral, we should have copper is +2. Yeah. Nitrate here is minus, so this should be +1 here. And here silver is 2, but it is alone, it should be 0. When you have succeeded in putting the charge on the metals or the elements, it means it's much easier for you which element is oxidized, which element is reduced. Now copper goes from 0 to +2, and silver goes from +1 to 0.
Reduce.
Remember,
one is
yeah, copper, remember that one. If you're going down, it means from 0 to +1 to 0, this +1 here, it goes to 0, it's going down, it means reduce. If you don't remember this one, common sense, it is a common sense. And whatever copper, from 0 to +2 oxidized. How many electron is being transferred? Of course, there's one copper, 2 electron will be lost, and these 2 electron will be get by 2 iron. Here is 2 electron as well. This is gain. Okay, this is why it's reduced. Here is loss. Is it clear now?
Yes, clear.
Teacher,
Anything else? Yes,
the total electron should be 2,
yeah,
because
yeah.
copper lost 2 electron. What about the Ag? It just gained 1.
Ag no 1, but there are 2 Ag.
Oh.
Can you see here?
Yes.
That's why each silver get 1 electron, but that's why we need to, the number of electron lost gain, they should be always same, equal. Here the silver need only 1 electron, it gain 1 electron, but we should have 2 silver now. Look at this, here are 2 silver. So 2 silver will get 2 electron. Clear?
The total
Yes.
2 electrons. Yeah.
Yeah, the total electron lost or gained, they are equal, so they are 2.
Clear.
Look at this one. Gain of electron is equal to loss of electron always. If 2 are lost, 2 should be gained as well. Clear?
Clear, teacher, clear.
One more thing, the last thing, I think, then we will finish this class. We did not complete the precipitation reaction, but it's not too much difficult. It's easy because we already mentioned here. The last thing is oxidizing agent. Do you see something here? I think we did not talk about the oxidizing agents here.
Yes, معاهم الاختلال معاهم الأكسدة. We cannot move. We cannot.
Yeah. Do you hear me?
Yes, yes, we hear you.
Yes. Yes.
Yeah.
We-
It's
we
very
cannot,
easy. Don't panic. Don't panic. Don't panic. Look at this. I will give you idea. Suppose here copper goes from 0 to +2. Is it?
Yes,
It is oxidized. Is it?
yes,
So this reducing agent. So
Yeah. Always. The element which is oxidized, it should be reducing agent. Whatever silver. Reduce. Is it?
yes,
yes.
reduce.
So it should be oxidizing agent.
معاهم الأكسدة.
What did you say in Arabic? I don't understand.
He translate, teacher.
Okay. It means this is the opposite one. Okay. If any element is oxidized, it should act as reducing agent. If any element is reduced, it should act as oxidizing agent. Clear?
Yes, clear.
This
So
is all about
all of this,
oxidation, reduction, redox reactions.
all of this considers the topic for redox reaction.
Yeah, redox reaction finish until here. We talked about oxidation, we talked about reduction, we talked about, even the oxidation number, how to know oxidation number, and how to know this element is oxidized or reduced. And then in the reaction, how you know this, which element, how many electrons have been lost or gained. In the loss or gain, they are equal. And then finally, we went to reducing and oxidizing agent. That's it.
And
This
teacher,
is the topic of, yes.
these types of question, as I said to you before, that's we need the periodic table, because we didn't know if the copper is a metal or non-metal. We should see the periodic table and see the position for it.
No. Actually, if I tell you periodic table, it's okay. But for this one, no need for periodic table, because you should know these common anions. Here, I don't need periodic table here in this question. Why? Because this is metal, molecule 0. This is silver. Silver is a transition elements. You cannot say whether it's a +1 or +2. You can find from the counterpart. So silver is like this, silver nitrate. Now you don't know what is the charge on silver, but you should find from the nitrate here. Nitrate is always -1. We studied already before the midterm. Nitrate is -1. Sulfate is -2. Okay, carbonate is -2. You should know all these common anions. Chlorine is -1. But the periodic table is always given on the top of your the black, when you open your quiz, or not in the quiz, I did not give you the periodic table this time, but in the questions, if you need periodic table, it will be there. But if you don't have the periodic table, it will be on the top of I think in the instruction place, you will find the periodic table there in the lockdown browser. There is one periodic table in the instructions. You can see anytime. And one periodic table, usually we give inside the questions. So the instruction is always open there. You can see it.
Yes, all the question in the midterm exam, it has a periodic table. All the questions.
Yeah. Most of them, they will have periodic table in the exam. But if you don't find the periodic table in any particular question, then you can see in the instruction place, in the first place, before even you can see the instructions. I think it will be visible for you throughout the exam. Okay, any question about redox reactions?
No, teacher.
No, thank you.
very much.
Okay, that's it. So tomorrow, inshallah, we will have the same time, 10 p.m. and we will talk about the rest of the things like precipitation reaction, simple, and molarity pH. We will talk about these one. How to find pH, how to find pOH, and what is the relationship of pH and pOH. If you have a pH, how to find hydrogen. If you have hydrogen, how to find pH and pOH. All these things, relation, we will have to study tomorrow, okay, inshallah, if you are there with me. Thank you.
Thank you.
Thank you, teacher. Thank you.
Welcome. Welcome.
Teacher. See you tomorrow, inshallah.
Inshallah. Okay, I'll stop the record.